Hi everyone, welcome back. Solving equations, looking at the x being up on the top, on the powers. We call them powers, we call them indices, we call them exponents, depending on where you are in the world. Most of the time in Australia we refer to them only as, we talk about the powers or the indices, or if it's singular, the index. Now these can go nuts. We can go crazy as math teachers and make questions. There's so many twists I could put on these to make it really hard. For those people who are confident, once you're confident with it, it's like there's nothing they can do to trick you. It's a matter of, do you understand the index laws? So if you want to go back and look at some of the index laws videos I've got, there's some index law videos there that will go through the basics and what's happening. So let's have a look what's happening here. This is a 2, this is a power of 2, and that's a power of 2. So if I look at my powers of 2, that's 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4, 2, 4 and 8 all fit on the powers of 2. So I'd love you to go home, and I keep challenging people all the time to go to sleep at night. You're laying there in bed and you close your eyes and you go 2, 4, double it, 8, double it, 16, double it, 32. If you keep going down, the 10th one, by the way, turns out to be 1024. So the 10th one starts with a 10. It's one of those funny little things. If I wrote it here, 1024 is 2 to the 10. So it's nice for memorisation that the 10th one in the pattern starts with 10, and rather interesting, it's got a 2 and a 4. There's no reason for it, it's just what happens, the way numbers have worked. So this is a 2, so I can leave that as a 2 to the x plus 1. This is a 4, so I want to write it as a 2 squared, because I'm wanting to get a base of 2 everywhere. But once you get a base of 2 everywhere, you can work out the answer to the question. Instead of trying to guess what the answer is, you can work it out. But this also has another x. It's almost like if I did that as 2 squared and go, oh, it's got an x. So you could go into understanding of why that x goes there, or you can just simply say, well, the x is there. It's actually 2 to the 2 to the power of x. And when you go a power to a power, you multiply. So this is 1 on 2 cubed. So if I wrote this 1 on 2 cubed, and then I go, well, what have I got here? When you're multiplying with the same base, the bases stay the same, so that stays as a 2. And what happens to the powers? So you add the powers when you're multiplying. I always talk about the multiplications become an add, the baby numbers, the little numbers, the indices become a addition. So what do we got? A 2x plus an x is a 3x. So 1x plus a 2x is 3x plus a 1. And let's go to see what we've got written over here. And I've got 2. So if I move it from a denominator to a numerator, if I move it from there to there, this has a positive. When I move it from a denominator to a numerator, it becomes a negative. So look at the red numbers, really they don't need to be there anymore. So there's our equation here. So if you wanted to write that equation down separate, you can. 3x plus 1 equals minus 3. Need to get the x by itself, I need to get rid of the 3, get rid of the 1. It's easier to get rid of the 1 first. So I can go, if I minus 1 from this side and minus from that side, most you won't need that, you'll see it in your head. So it's a 3x is minus 4. Divide both sides by 3 and your x is minus 4 on 3. You could write minus 1 to the third, minus 1.3 repeater, and on you go. Let's go to this one. 3 and 9 to the 27. So you go to your powers of 3, 3 and 9 and 27. So it'd be nice if you went to sleep at night going 3, 9, 27, 81. And you can keep going 243, 729 and go through the numbers. If you're familiar with them, it makes a difference. So this is 3. I'm going to bother to write it this time. 3 cubed to the power of x. This is 1 on 3. If I go from the denominator to a numerator, what happens to the index? This was a plus x. So it becomes a minus x. What do I do with a power to a power? I multiply, so 3 times x is 3x. If I again go from a denominator to a numerator, that becomes a 3 to the power of minus 2, and that's a 3 to the power of minus x. Go back to the basics of multiplication. If the bases are the same, we can add the powers. Bit weird when we say we're adding the powers because it's 3x plus minus 2. We can just write minus 2. You've got 3 to the minus x. Once you've got just a 3 and just a 3, that becomes the equation. So it's like saying all of this now becomes the brand new, I put EQN, that becomes the equation. We talk about equating the powers or equating the exponents. So you've got a 3x take 2 equals minus x. Most people watching this will know if I go plus x this side, I go plus x to that side, so that's a 4x. If I go plus 2 to this side, I go plus 2 to that side, that's 2. Divides over both sides by 4, and you've got 2 over 4, which you'd write as a half. Could write as 0.5. But there's a bit of a taste of some of them that become hard. It's whether I go to some really revolting ones and see what happens. Thanks for watching. If you're enjoying them, please just spread the word. Thank you.